741. Look up here, please. I'm sorry, 241. Page 241. All right, this is similar to what we did yesterday. We are looking to take one variable out of the game and replace it into the other equation. However, none of these variables are alone like yesterday. Do you see one variable that would make it really easy to get by itself?
X.
The x. Good. Focus your mind on this x right here. What would you have to get rid of? And how would you get rid of 3y? Minus 3y. Good. If we can know what x is by itself, then we can substitute it into the other equation and do it just like yesterday. Now, you don't want to do this for really complicated equations. You would use a different method that we're going to learn. Whoops, sorry, that's a y, isn't it? You would want to do it for a different method that I'm going to show you tomorrow. But for today, we'll do it when the x is basically by itself. 3y. Okay, now you can take what this x is and you can plug it into the other equation. Don't plug it back into the same equation. Plug it into this equation. 6y plus 5x.
That's the, oh.
The pen just skipped. And then equals 8. All right. Where does this go?
In the x.
Good. So take this x away and we're going to replace it. So everything else stays the same. 6y plus 5 times, instead of x, we put negative 3y minus 7. And then that equals 8. Now you distribute, of course, 6y minus 15y minus 35 equals 8. 6y and negative 15y, you know what that makes? Negative 9, good. Bless you. And then at the same time, we can add 35 to both sides, plus 35. 43? Let's see if it will. And then to figure out what x would be, you would go back and plug it in right here. X would equal negative 3 times, be careful, it's a fraction, but it's 43 over 9. And then it's minus 7. Why do we get a fraction? Because you have to divide both sides by negative 9. Make it negative. And then it doesn't reduce, so it's a fraction. And by here, the 3 and the 9 can reduce. You get a 1 on top and you get a 3 on bottom. And that's a negative times a negative. These ones right here, all right, which variable looks like the easiest one to get by itself? The y right here. You would accomplish that by subtracting 3x from both sides. Minus 3x and minus 3x. So y really equals negative 3x plus 18. Any questions on where that came from? You just subtract 3x from both sides. All right, now we have to use that. Let's use it in the other equation. 4x equals 3y minus 2. Which of these do I take out and replace?
The y.
The y, good, because it's y equals. So it's 4x equals 3 times y is negative 3x plus 18. And then you still have your minus 2. So that makes 4x equals negative 9x plus 54 minus 2. Correct me if I'm wrong on any of that. Negative 9x. And I think that's 54. You can check it in your calculators for me.
It is 54.
Alright, so then that becomes, we're going to add 9x to both sides, plus 9x, And then we're going to do 54 minus 2. 52, right? And now please divide 52 by 13 in your calculators.
We don't have
You should have a calculator every day.
4.
4, thank you. Alright, these will be better. It doesn't have all that fractions. So now we know that x is 4. How are we going to find y?
Look forward to it.
Good. And let's do it in this one because that says y equals, it's already kind of easy. So y equals negative 3x plus 18. Well, that's negative 3 times 4 plus 18 because x is 4. So it's negative 12 plus 18 and we get 6. Our answer is 4, 6. The 4 goes first because that's the x value. Alright, I'm going to show you an easier way to check it now, and you can use either way. But the other way of checking takes a lot of space. Even though I've been doing math for a long time, I still always mentally check it because I can make a simple mistake along the way. But this is how I do it. X is 4. So look up here. If x is 4, what's 4 times 4? 16. What is 3 times 4? 12. So I just write it up above. Now look at this. Y is 6. Y is 6. So what's 3y? 18. And then y here is 6. Okay, so now check it this way. Do you see what I did? I mentally plugged it in. So now does 16 equals 18 minus 2? 18 minus 2 is 16. So that one's good. What's 12 plus 8?
12 plus 6.
12 plus 6. I'm sorry. 12 plus 6. 18. So that means we did it right. So when I say check it, it's okay if you do it this way, but you have to do it one way or the other. And I'll show you this way one more time. Alright. So the last one here, number 4. Let me show you, and then you're just going to try some. I'm afraid I'm going to run out of room. You have it on your paper, but let me just do this. For number 4, which variable should we get by itself first? X. It's going to be a little bit harder because x isn't completely alone. But let's rewrite this one. 2 equals 2y minus x. To get x by itself, what do I have to move first? Yep. But that's not x. Negative 2y plus 2 right here equals negative x. What would x have to be then? Positive 2y minus 2. If you're going to change this sign, you have to change all signs, and you can do that. It's just multiplying by negative 1. Alright, I'm going to quit talking now, and I'm just going to write down what you told me to do. Now that I know that x by itself can be 2y minus 2, what do I do with that? Not yet. We already have x by itself. We want to use that x somewhere else. Let me rewrite an equation to see if you can see it. 23 equals 5y minus 4x. I'm rewriting the second equation here. What can I do with this x value right here? Plug it in. Good. You guys actually know that song? That's such an old commercial. You've seen it. 5y minus 4 times whatever x will be. X can be replaced by what can x be replaced by? 2y minus 2 is the same as x. So in place of this x, we use 2y minus 2. Take a second and let's solve this y together. I'm not going to say it. I'm only going to write what you tell me to do. Distribute, I hear. Is that right?
Yeah.
Double check my positives and negatives. Now what? Are you guys helping? And get?
Then you subtract 8.
Good. And what's our answer for y? Okay, that's a value for y. Is that done?
No.
We need to figure out x. How do I figure out x? Good. So x equals 2 times, what do I use for y? Negative 5, and then minus 2.
Oh, that's negative 10.
Negative 10.
Minus 2.
Okay, that's the work we came up with. Which one goes first?
Negative 12.
The x value, negative 12. All right, but let's check it. We have to check it and see. If you didn't finish copying, then copy that in. It's so easy to make one little mistake. There's a lot of work there. We could have easily forgotten the negative sign or done something simple as a mistake. So you have to check it. No matter how well you think you did, you still have to check it. So, look here. X is negative 12. Watch this. In place of x, I put negative 12. And what would 4 times x be? Negative 48. Okay, well, it'll become a positive after we do the double negative. The y is negative 5. So what's this right here? Negative 10. And this is negative 5 times negative 5? All right, so watch this. This is plus a positive. What's negative 10 plus 12? And it works, right? This is plus a positive. So what's 48 minus 25?
I don't know.
Well, what's 8 minus 5?
3.
3. What's 4 minus 2?
2.
So 23 works. Okay, you have to mentally check it to make sure that it works. Questions on that? All right, do these two together. You do not have these written down anywhere, but watch, okay? Just watch these. It's like problem 4, but I do not like the problems they gave you. Help me out with this one and let's see what happens. And get your calculators out to help me. What can I do in this situation? I could divide, but what do I have right here already?
You have x. You gotta get it by itself.
It's by itself, so now I can?
You can plug it in.
Good. 3.5 times x. What can I use instead of x?
Negative 2y plus 4.
And I want you to see what happens. Plus 7y equals 14. I need help with your calculators. What's 3.5 times negative 2? Negative 7y. What's 3.5 times 4? Hey, you guys.
Negative 4.
Negative 14.
They're both positive. Does it come to 14? Okay. Plus 7y equals 14. All right, now stop and think. One of the things about math is that...
that's what's it called?
Not quite. You're right that it's going to kind of go in that direction, but it's not quite that simple. This, look, the 7y and negative 7y, what do you get when you put those together? 0. So we're left with 14 equals 14. So Jesse, there's actually 2 possibilities. One could be no solution, or one could be infinite solutions. And here's where you have to decide. If what you have left over is true, then it's true all the time, and it's called infinite many solutions. That's just like the same line you're graphing. All right? If you get some where what you have left over is false, that's where you'll say no solution. So watch this last one here. Y equals 3x minus 11. Well, in place of y here, I'm going to use 3x minus 11. But then it's still minus 3x equals negative 13. You don't have to write this down, just help me. What happens right here? If I try to combine my 3x and my negative 3x, what happens? 0. But look at what I'm left with. A negative 11 and a negative 13. I have to ask myself, is that true or false? False. If it's false, you say no solution. Okay? That's the difference. I have to write down those of you that are just still talking. All right. So listen up. everything else is the same. You find one value for one variable and you plug it in. But if everything weird happens and you have the variables gone, Bradley, are you listening?
Yeah.
When all the variables disappear, you have to ask yourself, is what's left over true or false? If it's true, infinitely many solutions. If it's false, no solutions, and that's for the rest of the semester.